All right, this is Module 4, Lesson 2, which is over one-to-one and inverse functions. In the last lesson, we barely touched on inverse functions, and so we're going to get more into that one on this lesson. So a function is one-to-one if any two different inputs in the domain correspond to two different outputs in the range. So that's your definition of one-to-one. And I'm sure what you are asking is, okay, so what does that mean? So let's break down that definition. A one-to-one function must first be, right here, it must be a function. So we went over functions, I think at the beginning of Module 2, if not at the end of Module 1. For something to be a function, that means that every x value, there exists a unique y value. So in other words, no repeating x values. And when I look at that visually, it must pass the vertical line test. Okay, so that's what a function is. So for it to be a one-to-one function, well, first of all, it has to be a function. No x can repeat. So then it also must, for every y value, there exists a unique x value. So now not only is my x values not repeating, but now we have no repeating y values either. And when I look at that visually, it must also pass the horizontal line test. So what is the horizontal line test? For every horizontal line intersects the graph of a function in at most one point, then my function f is one-to-one. Again, for it to pass that horizontal line test, it says that it must be a function. So it needs to not only pass a horizontal line test, but it also needs to pass a vertical line test. So example 1, determine whether the following functions are one-to-one. So I just think this is funny. You have a domain with all of your guys, and you have a range with your girls. Is this function one-to-one? Well, if you look at the boys only go to one girl individually. Or I should say the girls only go to a guy individually. But when you look at the girls, we have a repeating value here. Phoebe is not only dating John, but she is also dating Chuck. Since Phoebe is being a not kind word, this is not one-to-one. So for this to be one-to-one, it would have to look the way Bob, Dave, Carla, and Deborah are looking, where it's just one guy is going to one girl, which is also going to the one guy. Here, we don't really even need to look at the x values because they're saying it's a function. But if you look, you've got -3, -2, -1, 0, and 2. Your x's are not repeating. They tell you that because they say it's a function. So to determine if this function is also one-to-one, we need to look at our y's. Is our y's ever repeating? We have 5, 3, 1, -1, and -3. They are not repeating, so this one is one-to-one. Example 2 says for each function, use its graph to determine whether the function is one-to-one. Well, they say use the graph, but then they don't give you a graph. So we'll have to make our own. We have x squared, and we have done this graph several times in this class. X squared is your parabola, and this one is the most basic one where its origin is right here in the middle. Again, it tells me it's a function, so it passes that vertical line test. But for it to be a specific kind of function, which is 1-to-1, it must also pass a horizontal line test. Well, this one does not pass that horizontal line test. So this one is not 1-to-1. This next one is x cubed, and we have dealt very little, honestly, with x cubed, but you can put that in your graphing calculator if you so wish. Go to y1 and put in x cubed. But it looks something like that right there. And again, it tells me it's a function, so I know it's going to pass the vertical line test. Does it pass a horizontal line test? Well, there's not a single spot that I can make a horizontal line to make it touch this graph twice. So this one passes the vertical line test. So this one is 1-to-1. So that is how you determine whether a function is 1-to-1 based on data points or the graph.